Alrighty, this is your daily reminder to watch all of my videos in their entirety with sound. So you have to watch them with your eyes, listen with your ears to the sound, and write it down as you take the notes. Okay, so our ISN page, I think I'm going to change that blank to date because we're not going to have an ISN page, but the date for this will be 8/26/20. That will help us keep up with things as well. All right, so I did the first couple videos in Cami to kind of model for you, but I'm going to do a better job for you if I'm actually up at my board in my classroom. Hopefully you can read my handwriting a little bit better. It's still not great, but I'll get it done. Okay, so we're going to talk about X and Y intercepts. Those should definitely not be brand new to you. You have no room for getting the X and Y axis mixed up or anything like that. I mean, this is pretty basic here, guys. So intercepts are points where the graph intersects. So make sure you understand the difference between those two words. Intercepts and intersects, those are two different words. So the intercepts are points where a graph intersects the X or Y axis. Okay, so we have X-intercepts and Y-intercepts. So here are my two X-intercepts. Could have more than two, could have less than two. And here's my Y-intercept. So the X-intercept occurs where, okay, so it occurs on the X-axis, but this line, the X-axis, is Y equals 0. So the X-intercept occurs anywhere Y equals 0, algebraically and graphically. And then a Y-intercept, my Y-intercept is on the Y-axis, and our vertical lines are X equals lines, and that's X equals 0. Okay? So a function, and we are talking purely about functions now, that's what we talk about mainly, can have 0 plus X-intercepts. That means maybe I don't have any, maybe I have 1, maybe I have 2, maybe I have 20, maybe I have an infinite amount. There's all kinds of possibilities. But at most, 1 Y-intercept. If you have more than 1 Y-intercept, then you're not going to be a function, and we're talking about functions. So it doesn't have to have 1, but if it does, it can only have 1. So we're going to identify the X and Y-intercepts of these functions graph below. So we're going to identify them graphically first. And here is an important little note, okay, because remember I said that notation is huge here, and you have to pay attention to how a question is being asked so you know how to answer it. So in this case, we're being asked for intercepts. And so intercepts are always ordered pairs. Okay, so if I ask you for an intercept, you have to give me an X and a Y value. So when you're talking about X-intercepts and Y-intercepts, you have to make sure that you put the 0 in the correct place. And remember, you have an X-intercept, Y is 0. A Y-intercept, X is 0. So you just told yourself right there. So we're going to identify the X and Y-intercepts of the functions graphed below. Okay, so for number 1, X-intercepts. Well, here's my X-axis. It doesn't intersect it at all, so I have none. My Y-intercept, it's right here. Now, most of the time we don't get to like guess off of a graph unless you're told to, but you can get yourself in a lot of trouble trying to pull a Y-intercept off a graph when it's not accurate. So this is at 1, 2, 3, 4, 5. So my Y-intercept is when X is 0, so this is 0, 5. Okay. So why don't you pause and do 2, 3, and 4, and then we'll come back and see if we agree. Okay, but I'm going to keep going, so you've got to pause. Alrighty, number 2, my X-intercept. Looks like I intercept the X-axis 1 time right there. That's at 1, 2, 3, 4. So I have an X value for my X-intercept. My Y value is 0. I'm only allowed to have 1 Y-intercept. If I have one, that's at 2. So I'm at 0, 2. All right, let's look at number 3. So in number 3, I have 1, 2, 3, 4 X-intercepts. So the first one here is at -1, 0. The next one is at 1, 0. Next one is at 2, 0. and the next one is at 3, 0. And I apologize, I probably did not give you enough room for that, especially if you're writing in Cami. I did make these boxes bigger, but it doesn't seem to have really helped. Okay, so then my y-intercept is right here. My x value is 0, and that goes to 6. Alrighty, number 4. So on number 4, and I had a question about this. I mean, we're not talking about domain and range right now, but somebody did ask me, or I was asked this question a couple of times actually, why like the domain and range weren't all real numbers. In this graph right here, this is a rational function, and you have asymptotes. There's an asymptote right here and an asymptote right here, which means you are never going to get, it's never going to cross the x-axis or the y-axis. Okay, so we can't include 0 in the domain or range, but that also means that since I can't cross the x-axis or the y-axis, I don't have any intercepts. So none for this, none for this. Okay, so x-intercepts and zeros, are they the same thing? They're not exactly the same thing. Okay, here's your definition of a zero. Zeros are the x values. So this is key. The x values, it's not an ordered pair. The x values where the function, and we're also specifically talking about functions here, where the function intersects the x-axis. So here's a key difference. If I ask you for an intercept, you are giving me an ordered pair. If I ask you for a zero, it is just the x values. Okay? So, to find the zeros, okay, it's where it crosses, or where it intersects the x-axis. That means that y is 0, but we're talking functionally here, so that means that f of x equals 0. Okay, so you set f of x equal to 0 or y equal to 0, and solve for x. To find the y-intercept, you set x equal to 0, which means you are finding f of 0. Okay, so let's do that. Let's look at this first example. Sorry, things are overlapping. Okay, I want to find the zeros and the y-intercept of each function. So I'm going to start with the zeros. Okay, so to find the zeros, I set f of x equal to 0. So that means 0 equals negative absolute value of x minus 5 plus 3. All right, so I need to solve for x. I'm going to take this whole term here and move it over to the left so I can make it positive. So I get the absolute value of x minus 5 equals 3. So then since it's an absolute value problem, I have two answers. Because this thing in here, x minus 5, so x minus 5 can equal 3, or x minus 5 can equal negative 3, because if I equal negative 3, I take the absolute value, I get 3. So that means then my zeros, and since I'm looking for just the x values, it's going to be put in a set. So here, this is going to give me, I'm going to add 5 to both sides, so I get x equals 8, and I get x equals 2. So my zeros are 2, 8. It's a set of numbers. All right, then my y-intercept. So to find the y-intercept, I find f of 0. So f of 0 equals the negative absolute value of 0 minus 5 plus 3. So that gives me a negative 5, which is negative absolute value of negative 5 plus 3. So the absolute value of negative 5 is 5, but then I got to make it negative, so I actually get negative 5 plus 3. And so f of 0 equals negative 2. Now this says y-intercept, which means my answer is an ordered pair, and my ordered pair is 0, negative 2. All right, so now something you have in your folder is the factoring polynomials flowchart. So here's a little crash course or a little reference sheet that I think can be very, very helpful. I put stuff on your summer assignment for you to practice factoring, so I would expect that you have practiced it and that you can actually factor, because if not, this year is going to be very difficult for you. But this is some special cases that happen. If you have 4 or more terms, what do you do? So you need to know how to take care of your special cases for sure. Sum and difference of cubes, difference of squares, and factor by grouping, completing the square if you need to. Okay, this is a very handy little sheet if you need it, because we're about to factor. So it says find the zeros in the y-intercept. So same instructions here. And so for number 8, I need to set f of x equal to 0. So 0 equals 2x squared minus 7x minus 4. So I have a quadratic. It's set equal to 0. So I either factor or graph, which we're not going to do to get it, or we are going to do the quadratic formula, which we are also not going to do. You're going to have to factor it. Okay, so I'll factor this one by grouping. I don't care how you factor. You don't have to relearn anything. It's totally up to you. Y'all aren't here for me to kind of poll you to see what you're most familiar with. But if I'm going to factor by grouping, I'm going to do 2 times 4 is -8. Then I need 2 numbers that are going to combine to give me -7. So that's going to be, oh goodness, let me turn that down. It's going to be -8 and 1. Those are my 2 numbers. So if I'm going to factor by grouping, it's going to give me 2x squared minus 8x plus x minus 4. And if factoring by grouping, again, if that isn't your thing, that's fine. I'm just doing it one way. I won't even work through this most of the time. So 0 equals, I can factor out a 2x here. That leaves me with x minus 4. Out of these 2, factor out a 1. That leaves me with x minus 4. So I get 0 equals 2x plus 1 times x minus 4. Okay, so then here's my 0 product property. So 2x plus 1 equals 0, x equals 4. So I get x equals -1/2 and x equals 4. So there are my 2 x's. So my zeros then are -1/2 and 4. My y-intercept, I want to find f of 0. That's equal to 2 times 0 squared minus 7 times 0 minus 4. So f of 0 equals -4. That means that my y-intercept is 0, -4. And it should have been pretty easy to see that you get this here, because if these both zero out, that's all you're left with. All right, let's look at number 9. All right, so I want you to pause and try and work number 9 without any outside help or aids of you doing photo math or anything else. We're going to try and factor this, okay? It is a quadratic, it is a quartic, because it's x to the 4th, but you can treat it like factoring a quadratic. Okay, so see if you can get this factored, and then come back. All right, so for my zeros, I'm going to make this 0 equals x to the 4th minus 5x squared plus 4. So I can factor this pretty easily. It's going to get me x squared and x squared. I need 2 numbers that multiply to give me 4 and combine to give me a -5, so it'll be -1 and -4. Okay, so now that I have this, these are 2 special cases. These are difference of squares. So if you didn't get this far on your own, pause now, factor your difference of squares, and see if you can finish this. Okay, so difference of squares, x plus 1, x minus 1. This would be x plus 2, x minus 2. So that means that I get x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So x equals -1, x equals 1, x equals -2, x equals 2. So I have 4 zeros. One way to write this is I could go from least to greatest and go -2, -1, 1, 2. But a better way to write this, since I have a -2 and a +2 and a -1 and a +1, to do plus or minus 1, plus or minus 2. All right, so then I have to find f of 0. That gives me 0 to the 4th. Oh, sorry, I got ahead of myself there. 0 to the 4th minus 5 times 0 squared plus 4. So again, those do 0 out, so I just get f of 0 equals 4. So my y-intercept, parentheses, because this is an ordered pair, is 0, 4. All right. Number 10. Okay, so pause if you haven't already worked this. Work this problem. Factor it out. Okay, or if you have to come back and watch me because you got stuck at some point, just watch until that point and then see if you can finish it out. Okay, so f of x equals 0, and so 0 equals x cubed minus 6x squared minus 7x. So the first thing you should always do when you factor is look for the GCF, and I do have one. So even though this is a cubic, this becomes x times x squared minus 6x minus 7. Right? And I can't drop this guy off. He's still important, so he has to stay there. At any point, I should be able to multiply this all back and get this. So now I need to factor this part here. So I get 0 equals x, and then I'm going to have two binomials. This will be x and x. Two numbers that multiply to give me negative 7, combine to give me negative 6, so that's going to be negative 7 and a positive 1. So I have three terms that I have to set equal to 0. I get x equals 0, x minus 7 equals 0, and x plus 1 equals 0. So that leaves me with x equals 0, x equals 7, x equals negative 1. So my zeros will be negative 1, 0, 7. Oh, my pen has a mind of its own. Very good. Then my y-intercept, f of 0 equals 0 cubed minus 6 times 0 squared minus 7 times 0. So f of 0 equals 0. So my y-intercept is 0, 0. There you go.